Have you ever looked at the sun and noticed some darker regions on its surface? Well, these are called sunspots, and they often appear in pairs or groups, which we call sunspot groups. Each sunspot has a central umbra surrounded by a lighter penumbra, and they appear dark because they are cooler than average surface temperature. In fact, umbra has a temperature which is about 1000 K less than its surroundings. Around the outside of sunspot group, you may see an area that is brighter than the normal surface. This is called a place, which is the French word for beach. French beaches often have white sand. That's why we use the term place for these bright areas around the sunspot groups. Did you know that the passage of sunspots across sun's surface has been used to measure its rotation period? At the equator, the period is about 28 days, but it increases with increasing latitude and is about 35 days near sun's pole. This effect is called the differential rotation. Sunspots are intimately linked to the differential rotation and how it affects the solar magnetic field. The sun's magnetic field is created by movement of charged particles. Its cause almost certainly lies in the convective zone, but no really good model yet exists. Imagine that at one particular moment, sun has a uniform bipolar field. Looking at the sun's face, we can imagine a field line just below the photosphere directly down to the center of sun's disk. Let's consider that the field and the surrounding material remain locked together in what follows. Now move forward by 35 days. The field close to the poles have made a complete rotation and be in the same position as seen from the earth. But close to the equator, it will have rotated an additional 90 degrees. So after 3 further rotations as measured near the poles, the field near the equator will have one additional rotation. You can see that the field being wound up and becomes more intense. It gains buoyancy and in places it rises in the loop above the sun's surface. While it passes through the surface, the magnetic field inhibits the convective flow of energy to the surface. So the localized region will be cooler from the surface in general. Therefore a sunspot appears. The energy that is inhibited from reaching the surface here will tend to reach the surface in an area surrounding the sunspot group, making the region hotter and brighter. This is called the place. The twisting of the magnetic field from its initial state gradually produces an increased number of sunspots observed across the sun's surface. This determines the sunspot number, which reaches at its peak after 3 to 4 years. Then it slowly reduces in strength for next 7-8 years when it finally becomes spotless. So as we have seen, sunspots are not just random dark spots on sun's surface. They are intimately linked to sun's magnetic field and its differential rotation, which causes the magnetic field to become twisted and more intense, leading to appearance of the sunspots. But why should we care about sunspots? Well, these seemingly small phenomena have a huge impact on our planet. Sunspots are associated with solar flares and coronal mass ejections, which can release huge amount of energy and particles into space, causing the geomagnetic storms on the earth. These storms can disrupt our communication system, power grids, and even the health of our astronauts. So studying sunspots and understanding their behavior is crucial for predicting and mitigating the effects of space weather on Earth. In fact, the study of sunspots and sun's magnetic field is an active area of research for astronomers and astrophysicists around the world. Observations like Solar Dynamics Observatory, Daniel K. Unoa solar telescope are dedicated to studying sun and its behavior, including the formation and evolution of sunspots. So next time you see a sunspot on the sun's surface, remember that it's not just a dark blemish, but a fascinating and important phenomena that can have a big impact on our planet. So thank you for watching this video. We hope that you found this information informative and helpful. If you have any questions or comments, please feel free to leave them down below. Don't forget to like and subscribe to our channel for more videos like this. And also don't hesitate to share this video with your friends and family who might find it interesting. Thanks for tuning in, and we'll see you in the next video.